Evolution can be a controversial topic with many individuals questioning its validity. So why is this theory so widely accepted in the scientific community? Just what is the evidence supporting evolution? There are vast amounts of evidence supporting evolution, from fossils to comparative anatomy to molecular biology. Here we begin our discussion with how fossils provide evidence for evolution. How did modern species evolve from their ancestors? Paleontology provides clues through the study of fossils, while the geologic timescale divides Earth's history into eras defined by geological or biological events, such as mass extinctions. Based on this timescale, it's now estimated that the Earth is 4.6 billion years old. Evidence of evolution comes from comparative anatomy, embryology, biochemistry, molecular biology, and genetics, besides fossils discussed in this section. A fossil is any evidence of an organism from more than 10,000 years ago. If you are digging a garden in your backyard and you uncover rabbit bones that are 2 years old, this does not constitute a fossil. Fossils not only provide information about their ancestors, but also about Earth's geography. For example, Oklahoma contains remains of extinct marine animals, indicating that a shallow ocean once covered this area of the U.S. Fossils are any preserved part or trace of an organism, such as dinosaur bones. Remains or impressions of dead plants or animals petrified or preserved in rock, such as the fish in the lower left-hand corner, are also examples of fossils. Progressive series of fossils and rock layers exist for many species, starting with the most ancient primitive organism in the lowest layer, followed by intermediate stages of organisms in the middle layers, and finally the more modern species found in upper rock layers. This being said, the fossil record is often incomplete, missing some of the intermediate stages or species. This is because many organisms don't leave behind a fossil trace, either decomposing or being eaten before being buried in sediment in one of the rock layers. Other fossils may be buried so deep in the earth that they cannot be uncovered, or they may be buried underwater. In this display, fossils of hominids, which are primates, are arranged from the oldest on the bottom to the newest on the top. As hominids evolved, the shape of the skull changed. An artist's rendition of extinct species of the genus Equus, which is the horse, reveals that these ancient species resembled the modern horse, but varied in size. As fossils are uncovered in rock layers, how do we estimate the age? There's two ways to estimate how old a fossil is: relative dating and absolute dating. Relative dating places a fossil into a sequence without giving a specific age. As we've discussed, fossils in deeper rock layers are older than fossils in higher rock layers. Absolute dating and radioactive decay assign a specific age to the fossil. This uses radiometric dating, which uses the half-life of a radioactive isotope to determine the age. The half-life is the time it takes for half of the radioactive atoms in a radioactive substance to decay. A radioactive substance has all atomic nuclei that are radioactive, or 100% of the sample. After one half-life has passed, half, or 50% of the radioactive nuclei have broken down. After two half-lives pass, half of the remaining radioactive nuclei have broken down again, or 75% of the total beginning sample. This will continue until all of the radioactive nuclei have broken down.